Hey everyone, thanks for joining. John here, software engineer with 10 years of experience. And today we're doing our daily Leetcode. So this is Wednesday, May 22nd. And Monday through Friday, I'm streaming Leetcode as I'm on my job search as a recently laid off senior software engineer at a FANG adjacent company. The Kata is 12 standard problems that cover most expected whiteboard interview questions, most expected types. And so 1 through 4, I have down pretty well. And so I want to jump into 4 as a warm up, and then 5 is my main sort of working problem right now, where I've tried it a few times. I think this is like maybe the 3rd session where I'm trying to remember how to do it. So we'll try it again today, and if I get through it, we'll start on 6, and if I don't get through it, then we'll just keep repeating 5. So here's linked list cycle. This is a warm-up question. Number 141 on Leetcode. Given head, which is the head of a linked list, determine if the linked list has a cycle in it. And we can see that this linked list is singly linked list based on the comment in the Python code. So we have a next pointer. We don't have a previous or back pointer. There's a cycle in a linked list if the node can be reached by continuously following the next pointer. So it's kind of like an infinite loop. We see an example here in 1. The prompt tells us that internally POS is used to denote the index of the node that tail's next pointer is connected to. This is not passed as a parameter. It's not really relevant for me as an engineer. I think that's just like a note. Maybe someone in the past accidentally used a variable called POS and there was unexpected behavior, so they just kind of give you that note. I don't expect to need to deal with POS. And then finally, the return value. So they want to return the value of true if there is a cycle in the linked list, otherwise return false. Okay, so here I'll do my targeted complexity. Intuitively, I need to check every node to know whether there is a cycle. So best time complexity seems like O of n. An obvious implementation is to use a copy of the list in array or string form. Nope, sorry. That's not right. What if I copy this list? I can't copy the list. I will time out trying to copy it. Yeah, I can turn it into a map, not a list. An obvious implementation is to create a scene map of nodes. Return true if a node is already has already been seen. And false if we run into a none. If we basically get to the end of the list, there's no cycle. That's a none. On second thought, we can stagger pointers and detect a loop by collision without a cache, costing only O of 1 space complexity, which is efficient. So let's do that. So I want to stagger these. So I'll have fast and slow. So what I'm doing here is I'm saying fast is going to traverse 2 nodes at every iteration. Slow will just traverse 1 node. So that's why there's a next.next in contrast to just a .next. And I want to do the navigation before I do the collision check. The reason is so that I don't get a false true on the first iteration where they're both pointing at head. Okay, so here, if fast is slow, that is they're pointing at the same index, I'll return true. And then if I break the loop because there is not a fast, so fast has become none, or fast.next has become none, or fast.next.next has become none. In any of these cases, that means there can't be a loop. There can't be a cycle. So I'll return false. Yeah. That's it. Super, super simple. Okay. That was our warm up. We are 6-7 minutes in. Now let's go on to palindrome linked list. Let's wipe out the existing solution. So we're still given the head of a singly linked list. We want to return true if it's a palindrome and false otherwise. We're guaranteed not to have a cycle. Time complexity. The efficient target worst case time complexity seems like O of n. This is a tip when you're interviewing. You don't need to definitively answer. You can use tentative language. You can say it seems like. And that's enough to unblock you from the prior analysis to proceed with the actual implementation of the code. Solo Leveling says, hello, what's up, what's up? I still need to watch that show. I haven't seen it yet. I'm in Black Clover right now. By the way, Black Clover is so good. Black Clover is so good. There's very few things that would make me leave being a software engineer. I love being a software engineer. But if someone was like, hey, you can be a voice actor in Black Clover, I would hesitate. I would pause. I'll be like, really? Okay. So we're guaranteed not to have a cycle. And so, but I do need to look like, what's a palindrome? Mom, dad, race car is a famous one. It's the same forwards and backwards. How can you stagger pointers if the loop is larger? So staggering pointers is maybe not the best jargon. Maybe that's throwing you off when I say that. The size of the loop doesn't matter. The size of the loop doesn't matter. As it grows, you can always move them at different rates, which is what the fast and slow are doing. So when I say stagger, it's just fast and slow. So one is just moving fast, moving like twice as fast as the other. If you like run track, if you're familiar with track and field, the sports, when we check for that collision, when we say, hey, is fast slow, what we're doing is basically checking whether the slow runner got lapped. Does that make sense? Fast was so fast, it came back around and lapped them. That means there's a loop. You don't need to know the size of the loop. Why would you need to know the size of the loop? Especially as it grows, it's just totally fine. The only interesting case would be if it's really, really small. So if the loop is like a single node, then it's like, how do you stagger these? But it doesn't matter because the while condition needs to ensure that a stagger step is possible. It was while fast and fast.next and fast.next.next. If the stagger step is impossible, you just definitely don't have a loop. And so you don't really need to worry about that case of length 1 or length 2. Did that make sense? Good question, Solo Leveling. Let me know if that made sense. Okay, let's hop back into this palindrome one. So for a palindrome, I need to like compare the whole string, DAD. I'll never know if it's a palindrome unless I look through the whole string. So it's going to have, seems like O of N. But what about the memory? Obvious. Don't you need to check dot next and dot next dot next? I did. Here, let's go back. Maybe you didn't see all the code. Do you see this one? Does that make sense? Is it too blurry for you? Here, maybe that helps. By the way, if I don't get to your question, you can pull up to the line 24. No, I don't need to check anything else here. So I'm checking it on line 18, so it's guaranteed by line 24. You see this? What are you using, Visual Studio? No, this is the IDE that's built into Leetcode. Okay, y'all, I'm gonna move on because I actually need to get through the code. But come over to latterly.io if I don't answer your question in time, or if you want more detail. You can sign up to the Discord for free, and after the stream, we can get to all your questions. Throw some likes on the video, by the way. That'll help the algorithm send it around to help other people learn. Okay, so I looked through the whole thing. How do I know if it's a palindrome? Simple approach is copy the list into a couple arrays or strings and check array equals its reversal. Uses ON memory. A more efficient approach is to mutate the linked list in place, then like by reversing the second half. Then we can pass through once and see whether it's a palindrome. It's palindromic with O1 memory. Do you do any C++? No, I don't. Is it wrong not to be able to code without chat GPT? It's not wrong. I mean, you might fail some interviews, but that doesn't, like, what do you mean wrong? Wrong is like a moral term, right? It's not like immoral. It'll make it darn difficult, if not impossible, to get a Google job, but I wouldn't call it wrong. Okay, so we have our solution defined now. So we're going to try to do this, this approach. How do you create an AI? Hey, that's pretty off topic here. So I'm not going to be able to deal with that question, unfortunately. Feel free to visit the Discord, though, and we can chat about it. Why are we talking about Angular, dude? What's up? BP in the chat. Makoto, thanks for the follow. I think he's just joking. Okay. So what I want to do is, here's my implementation to do. I need to find midpoint, reverse linked list after midpoint, and concurrently traverse and compare head to midpoint versus midpoint to end. So consider the case of DAD, D-A-D. We take that DA, and then we're going to find the midpoint, which is an A, and we're going to flip the A. So I have DA, and I would have DAAD, except that I flipped the copy. So I have DADA, and I'm going to concurrently traverse and say the Ds are the same, the As are the same on a second pass. How have the technical interviews been going for you so far? They've been going good, but I haven't had any like FANG code interviews yet. So I've done tier 2 ones and they were fine. I've had 5 first-round interviews so far in my job search. I have done 50 applications, 5 first-round interviews, 5 formal rejections, and then like 40 that I'm just like waiting on. Most interesting thing that I've been asked. Let's see. You mean for a technical round? Would you include like sys design in technical rounds or not? I think the most interesting thing that I was asked was like a system design question, basically. I was asked, yeah, I was just asked about the system design at my last job at Upstart, basically. I think that's pretty much the most interesting question I've been asked. Because, yeah, I don't know if I should get into that now, but it just is an interesting system. That's probably not what you're looking for, though, right? Because you're interested in... Do you mean, when you say most interesting, do you mean most difficult? I thought it was an interesting conversation, but it wasn't particularly difficult. I had like a HTML widget that I had to build where, like you have pagination and you need to click the next button and the currently activated page goes over. I had to do that in one interview. Most surprising? Yeah, I think the HTML widget one was really surprising because I was expecting like, it's like a React role. So I was not expecting to have to do vanilla HTML and JavaScript. Yeah, so that was surprising, but it's fine. Okay, let's do some code here. So we want to find the midpoint, reverse the linked list, and then concurrently traverse. Were you making something? No, well, I mean, kind of. It was like a little widget, basically, like a little HTML page. But that was just for the interview. It was not really a project. It was just like a one-off question. Do you think you could pass a coding interview with well-written pseudocode? Like almost never. Like almost never. But it's not impossible, yes. The interviewer is allowed to pass you. So technically the way these things work is the interviewer is allowed to pass you if they want to. It's just that almost nobody would do that. You're telling me you haven't been hired. Why? Well, I was laid off 2 days ago. Thanks for the follow. Hey, let me actually get back to coding, y'all. I'll give one more plug for latterly.io. Join the Discord. If I don't get to your question, I'll totally get to it on the Discord. Thanks so much for being active there on TikTok. If you're enjoying the conversation or the Leetcode practice, give the video a tap, and that'll help the algorithm send it around. Abhi says, where do you suggest to find mentors? Great question. Join the Discord. I'd love to talk to you about that, but I'm going to get back to this. Okay. So here I'll also use fast and slow. And then I will say while fast, okay? And that's it. And so then eventually we break. At this code location, slow is midpoint. And so I want to say reversed second half head is reverse linked list of slow. Reverse linked list of slow. And then here, we want to compare the first and second half of the linked list segments from head down. Does that make sense? So now we're at the DAD, we're checking D, then we're checking A on the next iteration. So here I'll say while head, and they both need to be truthy if either is none, treat as equivalent. Treat as equivalent. For odd length questions. So DAD is an odd length question, DAD. And so if I go to the midpoint and then I flip after that, I could check D and A. In that case, I've duplicated the A. An alternative is just that I drop the A. And so it's D versus DA. And I just treat the A versus none as truthy. That's actually simpler. I'm going to do that. So if head.value, let's do this differently. Let's call this first half. First half head is going to point at head, but then we will mutate it. So if the first half head is not equal to reverse second half head, let's not call it head, let's call it node, because it's going to traverse down, so it won't always be the head. So if they're different, then it's not a palindrome, right? But if we get all the way down here, then it is a palindrome. Then it is a palindrome. And then we will do navigation. We do the navigation here. So the first half head, first half node rather, is its own next. Cool. Weren't you doing this question 2 days ago? Yes, absolutely. Yeah, so the Leetcode Kata, laterally Leetcode Kata, here's blog article number 3, is a repetition-based approach. You want to repeat. Drill, drill, drill. That way you remember it. Interview time. It's really good for recall. Okay, so I think this is done, except that I don't have a reverse linked list method. So let's go implement that. So here's the head to reverse. So how do we reverse a linked list? This is always fun. So the end node before reversal is none. The end node before reversal is none. And what I want to do is flip that so that it becomes prior to my first node. So here I'll make a prior and I'll call it none. Okay, so I have a prior, which is none. And then what I want to do is I'll have the reversed head which needs to be my last one. And I don't need to assign that. I just need to return it. Return prior. Okay, so prior is going to get repointed. So first it's none, then it's going to be the first one, then the second, and it's always going to trail. It's going to lag by 1, so that while my linked list completes the navigation and terminates on none, prior will be pointing to the last node before none, and that's the one I'll return. So my while condition will be while there is a node to reverse. While there's a node to reverse, then we do the reversal here. So how do I do my reversal? To do my reversal, I'm currently on the current node is node to reverse. Okay? And I would like my current node, so my current node is currently pointing at next. Current node dot next is pointing at next. And what I want it to do is I want it to point at the previous one. Okay? So that's what I want it to do. The problem is if I do that, how do I traverse to next? Because now I've created a cycle. Now that I've set current node dot next is prior, I've just created a cycle. And in worse yet, in the base case, I can't traverse that because I went to none and I can't go anywhere after that. So I need, the solution here is to make a temporary variable that will allow me to navigate before I assign backwards. I can navigate before I assign backwards. So here I'll say node, I can just call it node to reverse. So node to reverse is cur node dot next. So this is an eager navigation. To prevent cycle creation. Okay, so my current node is the node to reverse. My node to reverse is navigated. All right. I think current node is still pointing at the old one at this point. This is not an intuitive naming strategy. I'll call this next. I'll call this next node. So I want to store ref to next node. So that I can navigate later after I break the ref on node to reverse. So this is what you can call like a temporary variable. We're just storing the reference there. So that if when I create the cycle, I can just escape hatch my cycle and like teleport over to next node because I kept the reference. So my current node, I don't know that I need this line, but whatever, let's leave it now. So my next node is cur.next. And now my current node, I'm going to set to point to prior. And now that I've used prior, the whole purpose of storing prior is so that I can point back to it. So now I don't need prior anymore. So now I can reassign prior. So now prior is the current node. Now prior becomes the current node. It'll be the prior at the next iteration. Let's see. This looks pretty good. This looks pretty good, except current node is node to reverse. I might want to put that value in those three, but I think it's fine. We can leave it alone for now. That looks pretty good. And now I just need to do my navigation. So now I need to do the navigation. So I store the ref so that I can navigate later. So now let's do the navigation. Okay. Maybe it's just like this. Let's take a look. List node has no attribute value. Oh, is it val? Okay, it's just val. That was accepted. Yay. All right, we got it. That's the first time that I've successfully done that from memory. And it's been 30 minutes and I got two pretty easy problems, but this one is a brain scramble unless you can remember how to do it. Welcome to Leetcode, babe. Great. One, two, three, four, five. I'm not sure that I need this line, but I'm gonna leave it there. Let's see. Current node, node to reverse. What if I just do this? Does it still work? Yeah, it still works. Okay. We saved a line. Great, go team. All right, now let's do clone graph, which we haven't done yet. Do it in C++. No way. So blessed. Are you looking for a job? Yep, sure am. How about you? All right. Given a reference of a node in a connected undirected graph, let's return a deep copy of the clone of the graph. Let's return a deep copy parentheses clone of the graph. Each node, that's fine. Clone sometimes means to generate a shallow copy in languages, but they're specifying, so that's fine. Do it in assembly. No thanks. Let me know if you get the answer though. So each node in the graph contains a value and a list of its neighbors. Oh, nice. It's like a pseudo, not the recursive one. So there's the recursive one is you're going depth first, and then the stack based is breadth first. So this is like a pseudo breadth first search is how it looks to me. And we'll time box, we're at the 34-minute mark basically. So we'll time box this to 20 minutes, which pretty much lines up with the hour anyway. Cool. So 20 minutes time box would be the 54-minute mark. So we're given a reference in a connected and undirected graph. Let's return a deep copy of the graph. Each node in the graph contains a value and a list of its neighbors. It seems really easy. Why is this a medium? Gosh, here comes my overthinking, which always happens. One of the reasons I love the kata is it actually allows me to avoid overthinking, which is one of my definite weaknesses. The problem is basically an overridden copy constructor. Depending on what you mean, maybe. Depending on what you mean, maybe. But I would avoid the word override there because we want to create a clone, which is going to be disconnected. Leetcode, more like neetcode. Hey, got him. Got him. Neetcode's the GOAT. Okay. For simplicity, each node's value is the same as the node's index. That's lovely. For example, the first node with val 1 and the second node with val 2 and so on. Okay. An adjacency list. Okay, is it just giving me the answer? You're going to use an adjacency list. All right, fine. CS gang, pull up. Welcome, welcome. Make sure to follow the channel. Good to see you here. Okay, so the adjacency list is the collection of unordered lists used to represent a finite graph. Whoa, thanks for the quick lesson. The given node will always be the first node with value 1. I feel like they're repeating themselves, right? Because they already said that the index is the value. The given node will always be the first node with value 1. Okay, they're repeating themselves. That's fine. You must return the copy of the given node. Okay, that's fine. So whenever you make a copy, don't like start at 0 or something. Start from the given node. You must return the copy of the given node as a reference to the cloned graph. Okay, that last bit is throwing me. As a reference, then it's not a deep copy. If you want me to return a copy as a reference, you're just asking for a pointer. You want me to return a copy of the given node as a reference to the cloned graph. Okay, I think that's poorly worded, but I know what they mean. What they mean is just return a copy of the given node, a deep copy at the given node. That's all they're asking. Just did this question today, TikTok spying on me. That's wild. The algorithm goes crazy. Please do not drop the answer. That's one thing that I'll ask. I mean, I'm going to time box myself, so if you can wait 20 minutes and then drop the answer, that's fine. Okay, so at a high level, let's do our time complexity. I can't copy the graph without exploring every node. So worst case target is O of n. And space complexity, I can't copy the graph without using O of n. So that's my target. Okay, thanks for the follow. Complexity analysis is pretty straightforward. So we'll start by creating a new node. Do I have a node type here? It has this like fake type or whatever. Can I just do this? I'm going to check if this errors. Yeah, it errors. None type. So this is not a real class. It's like a pseudocode. So what is node, like what is this? Is this just a dictionary? Bool has no attribute value. Okay. Can I see my console though? So it's not a dictionary. Let me copy this over. Maybe it's somehow using the class without defining it. Standard out is true. That's crazy. So it's running this in some sort of a wrapper that's already aware of a node class. That's crazy, but okay. Why is it saying optional? It's not optional. Like you're just a node. Oh, because it could be none. So let's handle that base case first of all. If not node, return none. Okay, that's easy. So now we're guaranteed to have a node. We want to make a copy. We'll call this res node is node. We'll return res node. And the value here is node.value, or val, node.val. So here to do, explore, graph, and populate neighbors. It's called neighbors, right? Neighbors. Give it some breathing room. All right, so this is the basic structure of the program. Thank you for the follow. Quick reminder, if you're on TikTok, you can go to my bio and get to YouTube or Twitch and see the full screen. If you're on YouTube or Twitch, thanks for being here. Hope you'll follow the channel. Feel free to drop a comment. Spider-Man, thanks for the follow. Are you the real Spider-Man? That's pretty cool. Is the real Spider-Man code? Awesome. So I can say while, so will this terminate? Will this terminate? I got a bunch of neighbors. I'm traversing my neighbors. This adjacency list thing is not clicking for me. Why do I care about the adjacency list? So neighbors is an adjacency list. Is that the idea? I'm thinking of a BFS stack, and what I'm not sure is a BFS stack and an adjacency list the same thing. That neuron is missing. That neural connection is missing in my brain. But it will be formed within 20 minutes. Is this the same thing or no, as a BFS like stack of things to explore? First node, what this output in is array of arrays. I'm really confused about this. I'm really, really confused about this. So every neighbor, okay, the way I'm going to do this is I'm going to build a stack, and maybe that's wrong. I'm going to build a stack. I'll explore using a stack. Okay. And so I'll call this to explore is this list. And what do I want to do? I want to go through every node and add it to this list that I need to explore. And my termination condition is when every node is in that list. Thank you.
You're welcome.
Is this daily? Yep, we coding daily. Monday through Friday anyway. Let's look at this example. 1, 2, 4, 3. 1, 2, 3, 4. 1, 2, 3, 4. You can't return the same graph. 1, 2, 3, 4. Graphs are new. The graph looks the same. 1, 3, 4, 2. The thing that's confusing me is that I'm expecting neighbors to be multiple, to be like a list. Neighbors if neighbors is not defined. Okay, neighbors if neighbors is not none, else it's a list. It's a list, right? So why does this look sort of like deterministic? So 1 is going to say that 2 and 4 are both neighbors. Thanks for the follow. So 1 is going to say that 2 and 4 are both neighbors. That's not clicking for me. So for every node, I can collect a list of neighbors, I guess. Like I can make a nested dictionary. I can make a nested dictionary of node definitions. Seems really inefficient. I taught this problem to a class and TA'd. Oof, oof, oof. That hurts. So is it inefficient? It seems inefficient. So I create a nested dictionary, but I do it in one pass. So it's really not, at least in terms of time complexity, it's on target. It's still O of n. Space complexity is also O of n. I mean, it's going to end up being like O2n, but that's still asymptotically O of n. This is a medium Shiba. So while there are neighbors, I want to create a node copy, explore or queue, or in queue, all neighbors. Okay, so if I do that, I have my node. I mean, that solves the problem at a high level. The particular implementation to me is not clear, but that solves the problem at a high level. Okay, so we can explore or in queue all neighbors, create a node copy. So here I have the res node. Cur equals node. Cool. Nested dictionary is a solid approach. Thank you so much. Would you say it's extremely hard work or doable, but a bit of a challenge? I think this is one of those things like once you get it in your brain, it's easy. Oh, on YouTube. Thank you for being here on YouTube. We have Anoop. Welcome, welcome. And we have Brian. Hello, Brian. I think it's hard. if you can't put the whole picture together, but then like once you see it, it's hard to unsee kind of thing, except for memory loss. Except if you forget and then you have to remember it again. So for me, the difficulty is in imprinting the memory on my brain. But once you have the imprint on your brain, it's like it's really easy. That's basically the whole Leetcode game. Okay. Yeah, the explore pattern here is not coming to me. So let's just do one step at a time. Let's do that one step at a time, and maybe it will blindly, fortunately, guide us. Okay, so I pointed a node. I say while I have neighbors. Okay, I do have neighbors. Create a node copy. Create a node copy. I already have my head node copy. What do I do with it? Copy is node, and val is val, and neighbors are cur.neighbors. Like, can I do that? That's going to create a shallow copy. That's the problem. So that's going to create a shallow copy. So the trick here is that I want to dive into neighbors and make new instances of them all. Maybe the problem is that I'm looking at this like a BFS, but it's really more like a DFS. Okay, so let's make a copy neighbors. And yeah, we'll just pass neighbors here. So here I can have copied neighbors. So this is kind of like more like a recursive DFS style. While cur.neighbors is not really even needed. It's not really even needed. Instead of while, I can just say like if. And then here's the result node. Yeah, really, I can just return this. Let's see. Okay, so this is more like a DFS approach. But I think it's fine. Damn, I don't have enough time to write out the DFS, but do DFS, bro. All right, we're at the 54-minute mark. Let's go check the solution and see if my high-level approach was right. We're time boxing. This is the right thing to do. Don't feel bad if you time box. Oh, shush. Sorry about that. Using BFS in Java. Okay, so apparently, I'm going to look at this even though I wasn't writing Java, but apparently the BFS approach works. So what did I have? I was going to have an explore queue. They have this thing called added. If it's null, return null. Cool, I did that. They have an array DQ, BFS1. This is a dumb name, right? BFS1, give me a better name. What are you doing here? So result is a new node with a value. I pretty much did that, right? BFS2, Not making it a good, I'm gonna get out of here. This is not, even if it's right, it's hard to understand what they're trying to say. TypeScript, let's read some TypeScript. Okay, so we're gonna clone the graph. If there's not a node, you gotta love the short circuit right there. You could actually do that in one line. If not node, return null. Okay, so cloned is a map. Okay, using a queue and a map. So I had this idea. So they're going for it. So let's say what they did. So I was going to have this explore queue, but the map thing wasn't clear to me. I thought of doing a dictionary of dictionaries instead. So here it does set node comma new node node.val. So the key is the node and the value is its copy. It's a node node map. Okay. This is actually really weird to me. So this is creating a parallel layer. This is a whole parallel layer. So you have a queue, the queue just starts with that. Okay, this was the bit that I was not calculating. You have to throw that node in to explore. For whatever reason, I was not thinking of that. And the while condition is while the queue has length. So you're tossing them out of the queue. Where is it purged? Current node is queue.shift. Yeah. That is what I was not remembering. That is what I was not remembering. So how to process the queue? You put it in there. I was thinking that the head node was external to the queue, that the queue would become like its children or something, or its neighbors. But here, the node itself is in the queue, and then you continually add to the self queue, add and purge until you get to an empty queue. Great. I like it. I like it a lot. This is actually really easy once you can remember how to implement DFS and BFS. Okay. Good. Let's look for a DFS. Chat was talking about C++. Do you know how to read C++? Let's go. I'm not going to write it, but I'll read it. What language is this? I mean, we were writing Python, but I was reading a TypeScript solution. I can pick up a specific language. If you want to read it in a specific language, let me know. So they're going to do DFS. Here is its own method called DFS with a neighbor vector. Here's clone graph. Whoa! The C++ has fewer lines than my Python. Their C++ has fewer lines than my Python. That's crazy. So you have a map. It's returning a map. That's weird. If it's null, return null, fine. If node neighbor size is 0, yeah. So I did if node dot neighbors. That's equivalent. Return clone. Clone is, this is like a short circuit basically. And then else you return the DFS. You return the DFS of the head node. The map is the part that's weird to me. What do you need this map for? for auto it cur neighbor. Too easy to do, so skip it. What's up, Dev? What does that say? Govindani? Dev Govindani, thanks for being here. No, we're not going to skip it because it's easy or difficult. The difficulty of the problem is not the attractor condition. The frequency of invocation within the interview context is the proper attractor condition. So we're going to grind on the ones that are asked. And it doesn't matter whether they're easy, medium, or hard. You're going to grind on the ones that are asked for efficient prep. See if we can find a Python one. Recursive and iterative, so it's going to be DFS. Code initializes a dictionary, old to new, to store mappings between original nodes and their corresponding cloned nodes. I don't understand the V plus E. So I explore every node. Yeah, and the limit V plus E is V, right? So if like in the limit, one of these is bigger and it will just be O2 of that. So, and can you have multiple edges between two nodes? So if I have node A and B, are they going to have multiple edges between them? A and B can have multiple edges because I'm your neighbor and you're my neighbor. No, I think it's still just one edge. I'm your neighbor and you're my neighbor is two expressions, but I think it's still one edge. Are you pursuing a computer science degree? No, I'm just on the job search. How long did you take to get a good understanding of code? Enough to get a job, it took about a year. Thanks for the follow, Spot. Well, it depends on your definition of good. I like to use the benchmark of good enough to get a job, so that took me about a year. Why do we call it OV plus E? How are you going to increase the edges? I see how if I have like 10 nodes, those 10 nodes, you could have a single line where they all have one neighbor. Or you could have like a complex set where one is multi-neighbored and there could be more edges. But in the limit, there's still a maximum number of edges where everyone's connected to everyone. And I think that's still a linear multiple of V, is it not? So in the 2 case, there's 1. In the 3 case, you could have 2 or 3. In the 4 case, I can do a line of 3. I can do a square of 4, and then I can sort of do a square with the interior crisscross of 6. So we went 2, 3, 6. So it is a nonlinear pattern. Okay. So it makes sense to track them individually. Yeah, okay, fine. Time complexity is V plus E. Fine. Yep. Going to school right now for computer science, cybersecurity, hoping to learn it through that. Yeah, I hope you learn it through that too. If you have any difficulty, drop by laterally.io. You can join the community. Even if you don't have difficulty, you can drop by anyway. It just helps to learn with a peer group, right? And yeah, some programs that will be enough. You can learn to code as part of the program, and some it won't. So I don't know what school you're going to, but good luck. Can you show me the question so that I can answer your doubt? Sure. What is my doubt? Here's the question. Can you do climbing stairs? Nope, we're not going to do climbing stairs today. We're doing the Leetcode Kata. Okay, so you saw a picture of the question, right? I'm going to go back to the answer because I'm just studying the answer at this point. I don't actually, in my mental model, I don't have a doubt. I'm just studying this answer. If node in old to new, return old to new of node. Ah, that's what we're doing. So it's not just for tracking for an exit condition. It's actually a performance boost. It's a short circuiting operation. Oh, and it also it does prevent us from going into an infinite loop, doesn't it? Thanks for sharing the live. Yeah, because if I have a square, if I run DFS on the square, and if I don't have an exit, if I don't have a cache, I'll just keep spinning. It's like a cycle. I thought you were stuck at the TC. I was thinking through it, yeah, but I convinced myself that it makes sense to track V and E independently. Convinced myself about that. Because they are increasing at different rates is the reason it makes sense to track them independently. They're different sets. They're different. They expand at different rates. They're not both linear. Okay, so return DFS node if node, else none. That's crazy. That's crazy. So this is just a straightforward DFS problem. I mean, you can do it BFS, but it's also just a straightforward DFS problem. I think why did that not stand out to me from the beginning? I think the reason is because connected undirected graph. I read that disconnected graph, which is why a DFS didn't jump out to me. But it is connected. It is connected. Thanks for the follow. Thanks for being here. Okay, bye. Going to sleep. It's 2 a.m. in India. Oh, thanks for being here. Hope you get a good sleep. See you. Sleep is important, right? Let me keep a link to this one. This is a good solution. Who has done this? It's called Rahul. Rahul Binair. Rahul Binair. This is a very readable solution. What I'm wondering, why do I pick a dictionary instead of a map? So let me copy this person's solution. And they even have the depth first approach here as well. That's great. Learned web development, had an intro in CS and got hooked. Been trying to learn on my own. Thanks for joining the community. Welcome. Learning on your own for most people is not an optimal strategy. I would encourage you to join the Discord. You can sign up for free. Join the Discord right there, latterly.io. Link is in the bio. You can also sign up on the website for free or start unlocking things for $1. But the piece that I would recommend is the Discord. You actually don't even need to be signed up for that. Okay. What I wanted to do was check whether I can use a map instead of a dictionary. So let me just copy this code over here. Let me first of all just run it, sanity check, the thing passes, yes. Now, here if I make, what is this going to be? Like, I want to call it like an exit cache. I'll call this the processed node map. Here's the processed node map. I followed, how often do you do lives? Monday through Friday, while I'm on the job search right now. That won't be the case in the future, but it's true for now. So if node in, we're just replacing all of these. Riley, thanks for the follow. Map is not defined. Did you mean lower map? Sure. Yes. Sorry. Map must have at least 2 arguments. What am I forgetting here? In Python, what is the Python map? Set. Oh, sorry. Set. Set does not support assignment. Wish I had time to stick around, but I'll watch out for your lives. Thanks. Thanks for being here. See you. What program is this? This is Leetcode. Leetcode.com. It's dict. That is a crazy username. DJJSJ. No, I know it works with a dict. Like, we know this works, right? We already know that. What I'm seeing is, can I use a set instead? Because the set will have a lower memory requirement. Maybe what you're saying is like, no, the set doesn't work. Maybe that's what you're saying. That's fine. I'll get there in a minute. So here I'm assigning node is clone. So this would be the dictionary. And what I want to know is, can I do this without the assignment? So what if I just say process node map dot add node? Set is not subscriptable. Return right. Okay, so in a BFS, this would be like a continue, but you cannot continue in the DFS approach. Maybe I could return none. Has no attribute neighbors. Where's neighbors? Node.neighbors. Where is it trying to grab neighbors? This is on line 26. For E and now.neighbors. What is so significant about laterally.io? It's just a social community. That's it. I mean, social communities are significant, but on the other hand, like, you could join another one, sure. This one, I highly recommend it for its evidence-based curriculum. Like, if you read through the Kata, read this article. So like, this is better than the Leetcode 150. This is better than the Blind 75. There's like a research basis to it, is why it's really interesting. Yeah, so Riley is saying that we have to use the dictionary. That's fine. I was just checking. I still want to see why the none doesn't work, but then otherwise it's fine. And so, yeah, one of the reasons that you would want to do this, it's like it's more efficient. You only need to study 12 problems to get the benefit that you would get for studying over 100 problems elsewhere, right? So this is one example. Lots of evidence-based stuff on the Latterly website to help you land your first or next programming role. So it will accelerate your career. That's the reason it's important. Okay, so why is this thing crying? Like, where is the issue? It's complaining in the driver, it says. Okay. I think it's returning none all the way up the stack. I think that's the problem. So if I have a test case, where's a test case? Let me actually look at a test case. The way they wrote these inputs is really weird. But let's just say I have a case where it's like neighbors 3, like 3. So 2, 3, 4, that would be a linear list. And we'll say that, yeah, it's a square. So this guy refers back to 1. Does that make sense? So you have a square because it's like 1, 2, 3, and then 4 refers back to 1. This is Python. Okay, so here's our test case. I come in here, I say, hey, you're 1. You're 1, all right? You're not none, you're 1. So I get in here, it's not yet processed. So I'm gonna go over here, I'm gonna create my copy. I'm gonna say, hey, I processed 1. Processed 1. I could do the node.val here as well. Does that fix anything? Recursion depth exceeded. Okay, so it's saying, let's do that. Yeah, okay. So I'm like, hey, I processed a value of 1. And now what about your neighbors? And you just have one neighbor. The one neighbor you have is going to be 2, okay? So I clone.neighbors.append. This is the weird part, I guess. Clone.neighbors.append. Why am I doing that? Clone.neighbors.append. Right. So it's not a straight dive where I just do like, I need to do a for child and neighbors. I need to loop on that. That's the part that I'm missing. Why do I want to do that? Why can I not just do a straight dive? Because the number of edges is variable. And that's the same reason that you would want to do the v plus e time complexity. If it was always one neighbor, if it was always one neighbor, or if it was always 2 neighbors, or if it was always n neighbors, then I wouldn't need to do that. I might still do it just out of, because right, if it's like always 100 neighbors, then that's just verbose. So I might just do it out of being concise. So clone.neighbors.append, where I was trying to do like copied neighbors and get them in one swoop. So why does my way not work? It works fine, except that it's just hiding the same logic. You still need to go through each of them. So it would create this array, and then you would get the array here, and then you would come over here and append the array. So yeah, you could do that if you want. It actually doesn't matter. You could do that if you want. You're going to do the same logic. It's just a different way to sort of abstract it. Makes sense. And so the reason that I can't do this is because none might come up the stack. And what's the problem if none comes up the stack? Return DFS of node if node, else none. So in my 1, 2, 3, 4 case, I get all the way to 4. All right, I get all the way to 4. And then 4 is going to say that, hey, I have a neighbor called 1. 4 is going to say, hey, I have a neighbor called 1. And my cache is going to say, I already processed 1, or at least it's already on the stack. I already processed 1. So you, Mr. Number 4, you, Mr. Number 4, are going to append none because I'm getting my cache exit. And so that actually breaks the representation because I lose that edge. I lose that edge right there. That's the reason that I can't return none. Really weird error that I'm getting from whatever is the solution evaluator. Yeah, it's a nested function. You don't have to. You don't have to. But that is just so that the process node map is within context. We can change it. Here, let me undo it. This is a good way to prove to yourself. Let's say that you implemented, like you copied someone else's code. How do you prove to yourself that you actually understood it? One way is just by refactoring it. And if you can successfully refactor it, that kind of proves that you understood it. Okay, so I changed the words, whatever, that shouldn't matter. But now let's refactor it to unnest the process node map. And that will give us another layer of confidence. Confidence is like a cake. We love cake, right? I mean, look at me. Look at that second chin. Your boy loves cake. And so we can grab this guy. We can go a couple places with it. One is we can go out here. Okay, so I expect it still works. I need the self. Self dot. So now I've moved it. Okay. So that works. The other thing I can do is I can, I have different options. I could put this on the class, and I could completely disconnect this from self if I want to. So you can do it any of those ways. It doesn't matter. Let's submit it and see if there's like a performance difference just for kicks. Look at that. We beat 94% of users. And now we got beat by 80%. It's just really high variance, whatever. Okay, that's going to do it for today, y'all. So the top level lesson for, like, what's our main takeaway for clone graph? And I already put in the patterns, like, I didn't read that. I didn't read that. But the main takeaway is that you can solve it either way, BFS or DFS. I like the DFS more because the code is less. But BFS is good too. It's good to be aware of that BFS, how you can add the parent into the queue. It's not external to the queue. The parent goes in the queue, and then its children are basically merged to become siblings. And then you proceed until the queue is dequeued. We'll see if I can remember it tomorrow. Thanks for being here. See you later.